E4, we have Alyssa's trying to move her massive dowry trunk. So we've got this huge trunk and it has a mass of 312 kilograms. And we're on a nice smooth level floor where the coefficient of friction is 0.287. So she can only pull with an applied force of 875 newtons. And she wants to know, can she move it if she just gives it a nice straight pull? Well, if she gives it a nice straight pull, of course her applied force is going to pull over here, but the other way we're going to pull with friction. So as long as her applied force is greater than or equal to the friction force, it should move just fine. If the friction force is bigger, then she's pretty much stuck. So we know the applied force already, we just have to find the friction force. So here, while we're on a nice level straight surface, it's just going to be mu mg. We don't have to put in the cosine because there's no angle. So our mu is 0.287, and the m we said was 312, and g, of course, is 9.81. So doing that, we find that friction is going to take 878 newtons of force, and she can only pull with 875 newtons, which means friction is winning this battle, which means she is stuck, not moving her trunk. So then she's sad. Then she starts thinking, well, what would happen if I have my trunk and I start pushing on it downward at 30 degrees? Well, of course, that means she's going to push down and forward, and her forward part, of course, is going to be smaller than the 875 newtons that she can pull with. And here we see that that's going to be a disaster because this is actually going to make it heavier, and this is going to be smaller than 875, so there's no way that this is going to work in situation B. That's right out. But in situation C, we start saying, well, what if she pulls upward at a 30-degree angle? That means she's really pulling both sideways and up. Well, if this is happening, of course, she's pulling with 875 newtons, and so what we want to do is, that's supposed to be a 5, she's supposed to be figuring out how much she's pulling both directions. So the sideways part here, of course, we're going to use cosine of 30 times the 875. And over here we would use the sine of 30 times 875. So to figure these two out, we find that the cosine is 758 and the sine is 438 newtons. Now, the 758 newtons is what has to beat the friction. So we say, well, again, my friction force is equal to mu times the normal force. And normally the normal force is just the weight of whatever this thing is pushing down. However, we've got 438 newtons that we are pulling upward with. So we're pulling up to fight part of that weight. And so we're making the box feel lighter. So we got to figure out, well, what is the total normal force here? So the answer, of course, is that the trunk's weight, of course, W equals mg. So the mass of the trunk was 312 times 9.81. That's a total going down of 3060 newtons, pushing that way, but then we said we have 438 newtons, that's pushing this way. So that means the total that we feel like is going down is going to be that 3060 minus the 438 for a total of 2623 newtons pushing down. So this is really our normal force. Well, of course, FF is just going to be mu times Fn. So all I have to do is take this number and multiply it by the mu, which was given as what, 0.287? 0.287 times that number. which gives us a beautiful grand total of 753. So we have 753 newtons of friction force, but lo and behold, look over here, we were pulling sideways with 758. So there you go, we've got a couple extra newtons, it's gonna squeak it by. She can move that dowry trunk. So she wins.